Hello and welcome. This is Abdurrahman Ayman. In this video, we're going to explore the surface class in RhinoCommon. So we're heading to the Rhino geometry namespace, and we're going to look for the surface class. And the surface class is actually dealt with exactly like the curve class. So you can construct an empty surface. You cannot construct a surface as an object like we did it with the line, like we did with the points, and so on. And in order to create a surface, you have to hit to the methods, and you can create a surface using an extrusion, and almost that's it. That's how you can create a curve using the curve class. You can also create a periodic surface or a rolling ball fillet and so on. So let's try creating an extrusion. It's a static method, and it means that we have to call the surface class name in order to create the extrusion. So we're going to type surface.create extrusion, and we will need the curve profile and the vector direction. Let's try and do this. So we're going to add a curve here and try to extrude it, create a surface that goes in the Z direction. And we'll set this one curve here and call it profile, and make sure that the type is a curve. And here all we're going to do is surface and call it a name, surface A equals surface.create extrusion. And here we're going to pass our profile, and let's call it vector, and add a vector to the inputs of the script, and A will be equal to surface A. And here if we run this and call this vector and make the type of vector 3D and add a vector here, XYZ. In this case we can use an let's say from 0 to 10, and here if we connect this to this vector slider and start adding a Z, we will find that we created a surface that is an extrusion of the curve with a vector. And if we change the Y component, we're changing the vector, and so we're changing the surface shape. Okay, we can create it using another method, which is a point. So we can create an extrusion from a curve to a certain point, and here we just check that this is a point 3D, and let's try to create a surface B. So surface B equals surface dot create extrusion to point, and here we'll pass the profile and the point that we added as an input, right? Okay, if we run this and make B, or let's make A equals to surface B actually, and let's add a point where we need our curve to be extruded to. So we'll add a point here, and we'll set one point which is here, and then we'll move it. Okay, if we move it to the Z, our curve will be extruded to this very point here, and it will give us shapes like this. So this is the other way to create a surface. So let's check the properties. We can check if it has a B-rep form. We can check a lot of things actually here, but they're not very handy actually. We don't use them a lot of times, but maybe the methods will be of a great help. So we can get a curvature at a certain parameters of the surface. So the surface has parameters just like the curve. The curve has a parameter in one direction, while the surface has parameters in two directions, which are the u and the v. So we can have a surface curvature, and this returns a type surface curvature at a certain point in the u and v directions. We can change the domain, or we can get the domain in a certain direction, or we can set the domain. And to set the domain, we don't just type dot domain. Instead, we'll find a method here that's called dot set domain. Okay, here dot set domain, and here it asks for the direction and the interval. So let's try this. If we want to reparameterize our surface and let that be surface A instead of surface B, in this case we can see that the length of this surface goes from 0 to around 17 or 18, but of course the length is a lot more because there are movement in the curve in the y direction. So in order to reparameterize this and deal with the surface parameters as from 0 to 1 and from 0 to 1 in the z direction, we can use the set domain. So let's say surface A dot set domain, and as we've seen before, this should return a boolean value, which is true or false. So we do not have to assign the result in a new variable. This changes the domain of this very surface here. So we'll say dot set domain, and we need to add the direction. So it says here the direction 0 for the u direction and 1, use 1 for the second parameter's domain, or the v direction. So 0 will be a new interval from 0 to 1, and we'll change the other domain. So we say dot set domain 1 and a new interval from 0 to 1. Again, what is this helpful for? This is really helpful because if I want to get a point at the surface, and this is of course a method in the surface class, we can find point at here, yeah, point at. This uses the parameters, actually. It does not use the length, the real length of the surface. So we need, if we want to get a point at the very middle of the surface, we can now get it easily by saying that point 3D point A equals surface A dot point at, and we'll add two doubles, which is 0.5 and 0.5, and this is the very middle of our surface. So if we assign this to a variable, we can say that B equals point A and run this and add the B, and here we have our point at the very middle of our surface. If we want to control this in a better way, we can just add U and V and add the U and V doubles here. So we'll call this U, and that will have a type double, and we'll call this V with the same type, and we'll go from 0 to 1. Okay, let's say from 0 to 1 with 2 decimals, and here. So now this is at 0, 0, this is 1, 0, this is 0, 1, and this is 1, 1. So we can get any point on the surface easily right now. And if we check in the surface, on a surface we can get a point at a certain length, actually. And there's one other very important method that is called rebuild, and rebuild is also a method in the curve class, but we didn't explore it in the curve videos, but let me show you where it is. So we need a lot to rebuild a curve. So if it has 3 points and we want it to be built on 5 or 7 or 10 points, we can use a function here or a method called rebuild, and it's down there. Okay, here we go. Rebuild, this one. So rebuild returns a NURBS curve, and we can add our point count, which is an integer. We can add the degree, change the degree of the curve if we want, and we can preserve tangents or not using a true or false value. Okay, getting back to the surface, let's try this on a surface. Let's try rebuilding a surface. So rebuild here shows us it returns a NURBS surface. So let's try creating a NURBS surface here. I know we didn't really learn the NURBS surface, we'll learn it in the next video, but let's just add a NURBS surface objects, call it surface C, and that will be equal to surface A dot rebuild. And here we're going to add the U degree, which will be 3, the V degree, which will be 3, the U point count, which let's make it 15 and 15 to feel the difference actually, and let's add surface C to the output and check what happens here. So if we run this, this works, but it gives me another surface. Maybe if we change the points to be 3, this will really change. So it will give me a surface that is built on a curve with only 3 points, right? In order to check this, let's get the curve here. 2 curves, surfaces. We're working with surfaces, so we need a surface at A. This is our surface, and a surface at C, and we can find here the difference. So surface C does not have the same smoothness of surface A because it's created from a curve that has less number of points. Okay, now what else can we do? I have to mention that exactly the same happens with a curve class. So if we let's just do it, because we didn't do it in the other curve video. If we make here a curve and add it to the X, let's just rebuild the curve. So we have curve X, right? So it will give me a NURBS curve most probably as the surface. So NURBS curve B equals to X dot rebuild, and here we can add the number of points that we want. So if we made it 3 and the degree to be 1, actually we're going now to create a curve that looks like a polyline, or it's actually a polyline, and here we'll say false. We don't want to reserve the tangents, and if we run this and it won't work, we didn't set it to A, so curve B. Now we have a polyline created from 3 points actually. If we increase them to 5, and because let's just hide this curve, because we changed the degree, it really changed. And if we increase the number of points, it will give me a smoother one. If we make it like 50, maybe it will give me almost a curve-like polyline because it has segments, it has more segments, so it's drawing almost the same curve here. And if we make this 3 with only 5, of course it's changing because the number of points changed. Here we had 1, 2, 3, 4, 5, 6, 7 points, and now we're using only 5 points. If we make this 7, it will give me almost the same one. If we make this true, it will change a bit. If we increase the number, let's say 9, and so on and so forth. This is how to rebuild a curve. Again, to the surface, we've seen the set domain method, and we can use the toBrep to make the surface a brep and get use of the brep class methods and functions and properties and so on. We can make it a NURBS surface actually, and we can transform the surface, so we can move it, we can rotate it, we can do a lot of things with it. This is it for this video. In the next video we're going to explore the NURBS surface class. See you then. Thank you.